In this video, we're going to look at the Lewis structure, the molecular shape, and the hybridization for H2CO. So the first step would be to draw the Lewis structure, which we could do by counting up all the electrons. Although I'm going to speed things up a little bit here. Hopefully we've done enough of these that you know that carbon has to have 4 bonds, and hydrogen has to have 1 bond, and oxygen has to have 2 bonds. So this is the only possible shape for this compound, only possible Lewis structure. You could draw the lone pairs on the oxygen as well, like so. Okay. So first of all, the hybridization we can get just by looking at the regions of electric charge around the carbon. We've got 1, 2, 3. So 3 regions of electric charge corresponds to sp2 hybridization. So like the nitrite we looked at last time, this is also sp2. But there's a difference in that there's no lone pairs on the central atom. So there's no lone pairs on the central atom to push these bonding regions away. Then these bonding regions are going to arrange themselves to be as far away from each other as possible, which means that they're going to have bond angles of 120 degrees. And this shape is going to be flat or planar. So the name for this shape is trigonal, because it's a triangle shape. Planar, just indicating that it's all flat or on the same plane. Okay, the hybridization for the carbon, if it's sp, so first of all we've got here, this is carbon in its ground state, it's 4 valence electrons, and if it's sp2, that means it's going to make 3 hybridized orbitals. So we have one of these electrons will be promoted, and we're left with our 3 hybridized orbitals and 1 unhybridized orbital. So let's just consider where the other electrons go. So we know that we've got a sigma bond. These are single bonds, so these are sigma bonds, and a double bond, you know, consists of a sigma bond and a pi bond. Okay, so sigma bonds with 2 of the hydrogens. So let's put, this is the 1 valence electron from one of the hydrogens. This is the valence electron from one of the other hydrogens. Okay, so we could write that down here, sigma with the hydrogens. And then you'll notice that we have a sigma bond and a pi bond to the oxygen. So we'll use green to show the electrons from the oxygen. So there's the sigma bond with the oxygen, and here's the pi bond with the oxygen.